Hello everyone and welcome back to Hacktivity Explained. And this is a very special episode of Hacktivity Explained because this time I'm talking about a book that I found myself and not a book found by another book bounty hunter. And this is a book that I recently found in a public book bounty program. Unfortunately, it has not yet been disclosed, so I can't really expose the target, but I couldn't wait, to be honest, for them to disclose it, so I just wanted to make this video. And the book I found was an S3 Misconfiguration. And if you don't know what that is, I made a video about it. But if you're too lazy to watch it or just can't be bothered, I'll do a quick explanation of what an S3 bucket is, and then I'll hop straight into a live example that you can also follow along with me. So an S3 bucket is basically just a file storage system provided by Amazon AWS. And the way it works is you basically just send a request to upload a file to it, and the file just sits in the system. And what's good about S3 buckets is that the company that owns the S3 bucket doesn't have to manage any file upload. That's all going to be managed by Amazon. And then it's obviously very secure because if you upload a file to your own systems, you have to worry about vulnerabilities, you have to worry about reverse shells, you have to worry about file upload vulnerabilities, which there's a very extensive list of. But if that's all handled by S3, that's on a completely different server. So if any vulnerability actually does occur, then it won't affect you at all. That's the great thing about S3 buckets. And here I just have a little diagram of how most of the time websites have users upload files to the S3 bucket. And this is a method used called a pre-signed URL. And the diagram is basically as follows. So in step one, the user sends a request to the website telling it that he or she wants to upload something to the S3 bucket. The website then contacts the S3 bucket and says, hey, this user wants to upload this file at this location in the S3 bucket. The S3 bucket acknowledges that and sends back a URL to the website, which will enable the user to go to the bucket directly and upload the file. The website then returns this URL to the user, and then the user can freely go to the S3 bucket and upload their file to it. That's how most websites do this, because if they had the user upload the file to the website directly, then it would be a lot more performance heavy. The user would have to upload a file to the website, and the website would have to upload a file to the S3 bucket. So if you imagine a file that's like 10 megabytes, the website would have to download the 10 megabytes and then upload it again. That puts a lot of work on the server, which most companies don't want. So instead of doing that, we can just outsource that work to the user and the S3 bucket and then basically increase our performance way up. So that's the great thing about pre-signed URLs. But if there is a misconfiguration here, for example, the website allows us to upload files to any location we want or access any other user's files, then there could be an issue here because we access the S3 bucket directly and all the authorization is handled externally by the server. So in this case, we could be able to access other users' files and the website could be misconfigured to allow this. So that's basically the vulnerability I was looking for here. And now I want to hop into the live example where I actually show you how I found this vulnerability. Yeah, so this here is my example website found on my bug bounty domain. And I actually want you to practice this yourself first before you watch this video. So if you're at your computer right now, then you can click off the video and actually go to this URL right here and then try to find this vulnerability yourself. If you manage to find the vulnerability, then leave a comment about it in the description, please. And now I'll just showcase what the vulnerability type actually is here. This is just a simple website where a user can upload an attachment and it'll basically show up. So this could be implemented in like hundreds of different applications, this kind of flow. Just the UI might obviously look a little bit different to it. Yeah, so the first thing I'm going to test in this application is going to be the file upload functionality. So in a HTTP proxy of your choice, or in Kaido in my case, I'm going to start intercepting the request, and then I'm just going to hit upload file. And let's see what that request looks like. Let's just send it to the repeater and stop intercepting. And this is what the request looks like. It's a multi-part form, and it seems like we have control over three parameters here. So the file name, the content type, and the key suffix, which I'm not sure what that is. We'll get into it in a minute. So we have sent a request to URL to the server, and here we've gotten back a URL. and this links to an S3 bucket. So this is going to be our pre-signed URL in this case. And whenever you see this, this is going to be a big sign that the website is using the pre-signed URL method that I just showcased before. And that means that it could be vulnerable to all those misconfigurations. So the way we're going to test for this is to see what the parameters we control actually do here. So starting off with this file name, I assume that they're going to influence the final URL that we're going to get back. So let's, for example, change this to test2.txt, and let's see what changes here. And it seems like this has changed the final kind of directory of this URL. And if we change the user path as well, it's presumably going to change this as well. But it seems like we are locked into some kind of directory here. And if I just send it again, it seems like this is a unique identifier. So you've been locked into a unique identifier, which isn't great. So the key suffix seems to represent the second directory, and then the test2.txt seems to represent the final directory. Now, what would allow us to access other users' files is if we could modify this unique identifier. It seems like all the attachments are going to be stored in assets here. And if we could change this unique identifier, we could access other users' files. That doesn't seem to be possible because we've been locked into it, and I don't see any way to change it here from the request. If we change the content type, let's see if that does anything either. And I'm not seeing it in the request, so I imagine that's not that relevant. Sometimes these content type parameters get put in, but they don't actually get used that often. They kind of just act as a representation for the server more than the actual S3 bucket. S3 bucket, it doesn't actually matter what content type the file is because the S3 bucket only stores the raw data in them. So that's all I can find here. One thing we can also test for here is some kind of path traversal. So sometimes what a website might do is it might normalize the path before it passes it to the S3 bucket. That's obviously not good. It's going to lead to a path reversal. So we're going to be able to change the path that the S3 bucket actually goes to, and then we're going to be able to write our file to unintended directories or access a file at unintended directories. So if we try like some kind of path traversal payload here, and I'm not seeing it in the request. So perhaps there's a filtering system. What if we put something like URL encoded path parameter, and it seems like it's URL encoded. So that kind of limits our ability to do a path traversal here. Could try a backslash as well. But that also seems to be URL encoded. Although that would potentially work as a path traversal payload, but in this case, since the website isn't normalizing the path, I don't think this will actually matter because the S3 bucket actually takes the literal absolute path as the file name. So the S3 bucket is not going to perform any normalization on this, and this just becomes the actual name of the file. So this path traversal idea doesn't seem to be particularly useful, and I don't think it's going to change if we try it on the other parameter either. So I'm not seeing any great ideas here. I don't think this upload functionality is currently vulnerable. And let's see what the get fetch vulnerability, let's see what the fetch functionality is looking like. So I'm just going to inspect this here. And it seems like this is a link that's also pointing to a pre-signed URL. And in this case, it seems like it's actually server rendered. So we might be able to check using the intercept. Sometimes what happens is this link, sorry, this link comes from a request made after the website is loaded, so kind of like a JavaScript request, but sometimes it is server side rendered. Now this is a PHP website. It's unlikely that it's using React, so more than likely this is server side rendered, but we can just refresh the page to actually verify that. Go and see this request. We're just going to forward it, and there's no other requests that are being made, and we see that this all the test files that we tried here have appeared, and yeah, so this is server side rendered. So more than likely what's happening is these assets are stored in some kind of database behind it where their actual S3 path is being stored here, and the website is actually creating this S3 path after. So every time I load this page, it's going to make a request to the S3 bucket, and it's going to create a pre-signed URL that's going to let us access this file. From this, we can kind of determine what the flow of the attachment creation system actually looks like. So what happens is the user makes a request to the server telling it that he wants to upload a file. The server sends a request to the S3 bucket asking for the pre-signed URL, but the server also stores the S3 path of that file inside a database where it will get it after and allow us to make a GET request to it. What the vulnerability here could actually be as well is if we manage to modify the S3 path in a way that corresponded with another user's attachment, we could not only overwrite it, but then we could probably also access it because we would be able to get it here. The server would log it in the database, and as long as we don't override it by sending a request to the S3 bucket, we will actually be able to access it as well. So a big thing that you can do with this actually is to look at the JavaScript. Developers hide a lot of things in JavaScript. JavaScript is really our friend here. So we're going to look at what the JavaScript for this looks like. It will not look nearly as neat as this, right? There's absolutely no chance it will look like this. It'll be webpacked, it'll be obfuscated, it'll be minimized, which is very unfortunate. So you're going to have to really look carefully, and you're going to have to basically try and decode the thing here. It's not going to be as easy as this, of course, but we can see the JavaScript here very cleanly. So what's happening here? So it seems that once the DOM is loaded, then there's a form that's being listened to here, which I imagine is this button here. We see our key suffix parameter that's being used as well from some kind of document element. But we see another parameter called S3 path. And this parameter is interesting because we didn't see it in the request, but it seems like it's being stored in the JavaScript here for some reason. And it doesn't actually get appended onto the data. Perhaps this is a deprecated parameter, which sometimes happens. Developers make changes later on, they add security updates and stuff, and maybe they want to basically keep some of the dependencies here. So this has probably been deprecated and it's no longer used, or perhaps the functionality is still there, right? So let's have a look at this. So in our original request here, what would happen if we tried to use this S3 parameter? Let's have a look. Let's have a look at this S3 path parameter. Let's use this instead, and it seems like we have gone straight back to the root directory. That's interesting, and the file name isn't there anymore. So we can probably get rid of this. Let's see what happens now. Oops. Okay, apparently file name is required, so we'll just leave that there. But now it seems like we can control the entire directory, which is very interesting. Let's rename this as something like leak. So what we can now do is basically find any file on the S3 bucket that we know the name of. Because we have the S3 path and the server uses server-side rendering to fetch the path. So if I request this, some of the new stuff should show up. Oops, I have my proxy on here. Oops. Turn this off. So obviously the new files are coming on. But the file that I actually want to access here is called secrets.txt. So this is a file that I put in that basically will prove to us that the vulnerability allows us to access any file. Yeah, so the file that we actually want to access is called secret.txt, not secrets.txt. And once we hit this, it'll load it in. Then all we need to do is refresh the page so the server creates that GET request for us, like so. We click on this button here, and we have read some kind of private attachment which I've seen, and this is just going to basically prove to us that we have actually unauthorized access to S3 attachments on the server. So that's the vulnerability there. What can we do with it if we say don't know what the ID parameters are? So the first thing I would do is try and enumerate this S3 bucket. So this is actually what I did, right? So using something like automate here, we can put in our injection parameter, and we can basically have a list, like something like directory list treat medium, and then we can generate these S3 pre-signed URLs for every single one of these, and then we can check if these files exist. So what we're looking for is some kind of sensitive files, like a .environment file, some kind of API key that developers might have left in. A lot of developers have this nasty habit of leaving a lot of sensitive files on S3 buckets, thinking that there's no way anyone's going to access them. But if you find a vulnerability like this, then obviously you'll be able to access any file in the S3 bucket, so you'll start looking for the most common ones, and you might find some developer API keys. If you find that, that'll go straight to a critical vulnerability, so that will be really good for you and a really good payout. Fortunately for me, developers in my program were quite smart, were quite diligent, and the S3 bucket had absolutely no sensitive data that I could find at all. So I had to move on to something different. And what I actually did was I used something called OSINT data to basically find IDs of different attachments that I could possibly find. So if we go back to our request here, you can see the the domain name for the S3 bucket, and that's obviously going to be public. So even if I go online, like something like this, I could visit it, and yeah, I can access it from the internet, right? What that basically means is that other people can access it, right? So other people have clicked on it and accessed it. And what we can do is we can use these web scrapers, so something like virus total, to enumerate different IDs. So when people click on these kind of on the attachment links to the S3 bucket, virus trackers like virus total will actually log this in some kind of system that we can read later. And the way we can do this is with something like a tool, like let me try this off here. Yeah, so using a tool like way more URLs, I was actually able to enumerate over 300 attachments owned by other users on this website. So on the S3 bucket, basically by using those virus total scanners and stuff like that. And if I run it on my test bucket, I don't think it'll return anything, just because I basically just created it yesterday and it's unlikely that anyone has visited it. But if you do have an S3 bucket and you have managed to basically find out how to access any file in the system, but you don't know how to show impact, this is a great way to do it. You can run a tool like way more URLs and enumerate attachment IDs owned by other users. So that was basically the vulnerability. What the impact of it was, I could access any file on the S3 bucket, but the challenge was that I couldn't actually find anything sensitive on it, and the attachments were behind two UIDs, kind of the same way they were here, which weren't really guessable for me. So if I didn't find out another way to get past that challenge, I would have basically just been like a low vulnerability because I couldn't access anything. However, I was able to use OSINT data to collect over 300 attachments owned by other users, and based on that, at least one of them probably would have contained like API keys and stuff like that. And files on the S3 bucket also never expired, which is something that I realized there's no expiration date for them. So a user couldn't even delete the file on the S3 bucket, right? It was just there forever. So chances of there being some kind of API key was pretty big, and that bumped it up to a high impact vulnerability. Missing out the critical because I couldn't really choose what kind of information I was able to find. I couldn't access all the attachments, and I had to choose from these 300. If I could find a way to access all the assets in the S3 bucket, or if I found a way to access some kind of sensitive data in the bucket, then I could have actually bumped it up to a critical vulnerability. If you have any idea of how I could have done that, then you can leave a comment in the description saying, sorry, in the leave a comment below saying how I could have done it. And also, if you manage to find the secrets.txt file, then you can also leave a comment about it and tell me if you actually enjoyed this example website. And last thing, if you did actually enjoy it, then I have a lot more of these kind of practical side labs in the description in my course. And it's basically 12 hands-on labs that are all found online. There's no need to download anything. And it's just kind of this practical side. Here I'm just talking about the theory and it's good. And hopefully you actually went out and followed along with this video by going to the website. But you do need to get a lot of practical side in for bug bounty. I had to actually do a lot of work in order to find these vulnerabilities. I had to do a lot of CTFs. I did a lot of something called like pen tester labs, where I did a lot of work on that. I actually went out and analyzed a lot of JavaScript myself. I wrote a lot of JavaScript, which is one thing, like making the course and stuff like that. So It's really helpful to get the practical side in, and if you do want to get that, then link in the description. Personally created labs for you. Yeah, so for this vulnerability, I got paid $2,500. Not a bad payout, I would say. Definitely one of the bigger ones I've gotten. And I also hope you enjoyed this explanation video of how I made that money. If you did, then do leave a like and subscribe so you get more content like this recommended to you in the future. And you can also watch my previous episode on Hacktivity Explained, where I talk about not me, but other bug bounty hunters. I think the previous one is on oh yeah, it's on client side path traversal. That's what it is. I also have a video about that, so you can go watch those two. And anyway, that's it for me. Thanks for watching and happy hunting.